Today's lesson, 3-3, is on System of Inequalities. If you remember yesterday's lesson, it was on linear equations, and now we're going to do inequalities, meaning we have greater thans or less thans, greater than or equal than, less than or equal than, and we'll have to shade. Unlike the equations that we did the other day where we were able to solve them by elimination or substitution method, the only way to solve a system of inequalities is by graphing and then shading the overlapping area. So here we go. We're going to have to graph. And remember, the only thing that you need to graph is 2 points, and you can get those 2 points any way that you want to. I would suggest probably putting them into y equals mx plus b form first. So let's do that. So here is the first one. When I get it into y equals mx plus b, I start at 3, I go up 2 over 1, and I do a solid line. And then we try out 0, 0 right here. We put a 0 in for y, a 0 in for 2, and it says 0 is less than 3, which is true, so we shade down. Which we knew we were shading down because it was a less than anyways. The other one was already in y equals mx plus b form for us. So we start at 1, the y-intercept. We go up 1 to the left, 2, because it is a negative slope. And then we plug in 0, 0 again. And this time we get 0 is greater than 1, which is false. That's why we did not shade over it. We shaded away. We shaded above. Again, we knew that it was above anyways. And then we're supposed to put these two lines together and shade just the overlap. And there you see the overlap is this area right here. This is where those two shadings overlap. So that's all of the area that would be a true statement for both of these inequalities. Go ahead and pause right now, and I want you to try these on your own and then start it back up and see if yours matches mine. Okay, so here we have my 3 graphs. The first graph, I got the y equals mx plus b form. I started at 2, went up 1 over 2 and made sure it was a negative direction. Second one was already set up for me, so I started at -1, went up 1 over 1, making sure I went in negative direction. And then I shaded the overlap. I will tell you that I don't ever do 3 graphs. I do it all on one graph. So I'm going to erase this one and show you how I do it. So I do get them into y equals mx plus b form first. And on one graph, I go ahead and graph the line. And I try to be as straight as I can, but whatever happens, happens. And then when I go to shade it, it's less than. I know I just do things like this to show the shading is going to go in that direction. Then I graph the other line, starting at -1, going up 1 over 1, and hopefully these things will cross somewhere up there. And that's a greater than. And then maybe use a different color to show that they shade up this way. And I look for where the shading crisscrosses, and it crisscrosses all in there. And I just do it all on one graph. It does not matter to me how you want to do it. You can do 3 graphs, you can do 1 graph. Just make sure you do a graph. So math loves to throw word problems at you. So we're going to go ahead and use a system of inequalities to solve this word problem. We have a cultural center that's sponsoring a concert. They want to raise at least $30,000. So my first thing I see is this word at least, right? So that's going to be a less than or equal to. It says the tickets are sold for $20 for balcony, $30 for orchestra, and the center has 500 orchestra seats. How many of each type must they sell? So I need to be able to make 2 equations, 2 inequalities, and so I better have 2 totals. So here's one of my totals. I have 500 orchestra. Here's my other total, $30,000. So I need to sell less than or equal to 500, and I got to make more than 30,000. So the first thing we should do is to define our variables. So let's call x the balcony seats and y the orchestra seats. It doesn't matter if you have those mixed up. You can see here, if you look at this first thing that we're talking about here, if I'm using the $30,000 as one of my totals, which I have to do, then I have to have money involved in the seats. That's why that 20 and that 30 are there. This is just number of seats, so it doesn't have like a value other than that, so I can leave it just orchestra seats. And now that I have defined them, I can replace those with X's and Y's, and here's what it looks like. So $20 times a balcony seat plus $30 times an orchestra seat. When I add all of the things I've sold together, I have to make at least greater than or equal to $30,000. And I can't sell more than 500 orchestra seats because there's only 500 to begin with. The question is, what if I sold all 500? Would I meet my goal? Well, what's 500 times 30? Yeah, we didn't meet our goal, so that's not going to be able to help us. So let's go ahead and on the next slide, we're going to graph this. So here we have our graph. The blue shading is the money one, where we are set equal to the $30,000. The red shading is the orchestra seats. And you see that right over here is my overlap. Now, this doesn't really make a lot of sense because I've shaded into the negatives and I can't have negative seats. So really all of this stuff right here is where we're looking at down in there. All right. So we take a point, we plug it in, see if it works, and that's where the shading goes. But again, that's how you do it. By the way, I did this graph in Desmos. You should all already have that downloaded. And I don't mind you guys using that to test some stuff. Not allowed to use it on a test, obviously, but when you're doing your homework to see if your graph is right, go ahead and throw it in Desmos and see if it matches up. Don't use it on a test. And just because we can make things a little bit harder. We can throw some absolute values in there. Remember, absolute value creates a V right there. See the V? The graph is going to look like a V. If you see plus or minus signs, that means the vertex is going to move around. If you see a negative out front or in front of the X, that means the V will flip around somewhere, either over the X if it's on the outside or over the Y on the inside. And if there's a number in front of the X or in front of the absolute value, that's like your slope. Remember, air quotes, slope. So let's go ahead and graph these things. The first one, Y is less than or equal to 3. Well, I don't see an X and a Y, which means I can't touch the X and the Y axis. I can only touch the axis of the one that I see, and I see a Y. So if I can only touch the Y axis, that means it must be a horizontal line. So there it is, and it says less than. Well, less than is down. All right. The second one is a V. I notice that there's a minus sign. When we have parentheses inside the absolute value, there's parentheses, even though you can't see them. We have to set that parentheses equal to 0. So we change the sign, it becomes positive 1, divided by the number in front of the X, which is a 1, and we get positive 1, which means to the right 1. So the vertex is going to move to the right 1, but it doesn't move up or down, so it looks like that. And since it says greater than, I knew that I had to shade up. So where do these two things overlap? Well, if I put them on the same graph, there's the overlap right there inside the triangle. Again, I do not create 3 graphs. I'll put one line on this graph, and I'll put the V on there, and then see where my shading overlapped. But you can do it however you want. So this is it. This is the last one. Go ahead and stop the video. Try these two on your own, and then check with my solutions. Okay, so here is my solution to this one. I started out with the line, started at 1 on the y-axis, went up 1 over 3, made my dotted line because it's not or equal to, and then I made my V by moving to the right 1, not up or down, and then I had a, air quotes, slope of positive 2 over 1, so I went up 2 over 1 in both directions to make the V. Shaded above that, or yes, above that V, and this was a mean one, but there is my overlap, that little tiny area right here in the middle, right there. All right, that ends it up.